Thank you very much for the invitation. I should say that to begin with, I was a little surprised to be invited. That's because I've never self-identified as a person who works in adult numeracy. But actually, I think I was wrong in that assumption. Anker's plenary at the start of the conference and other talks that I've listened in on made it clear that I am actually working in adult numeracy in various ways. And what's more, that I have been for decades. Just a few examples of how that is. I should share my screen while I'm talking about this. That's the one. As Jeff mentioned, I worked at the Open University for a long time, 36 years, in fact. People may not all know about the UK's Open University. It has many individual characteristics. The students do, on average, tend to be older than students in most universities. But the key thing is that entry is open. That is, students don't have to have a particular school level or 18-year-olds qualification in order to enter. I've done a lot of teaching of what might be called service teaching with people whose main interest is in other subjects, so teaching them about statistics and some elementary mathematics and things like that. And then numeracy levels could be really quite low in that context, and that meant I had some experience of that. What I've done in working with journalists, as I hope I'll manage to explain later, is got some very strong links with adult numeracy. I do some other things which are relevant to concerns that have come up in the conference. I'm a member of the committee of the Royal Statistical Society's section on data ethics and governance, and that has a lot to do with what we've been talking about in all kinds of levels. So I suppose I'm like that Molière character that found out he'd been talking prose all his life without knowing it. So I've been doing adult literacy in various shapes or forms for a very long time without actually calling it that. Okay, I should just, no, that won't work. Right, so I now have to make sure this works. Right, okay, so this is what I'm going to talk about. In this slide, I refer to statisticians. Actually, it's a bit too narrow. I'm a statistician, and I usually talk to statisticians about this sort of thing, but it's wider. It would apply to other people in the mathematical sciences, in mathematics education as well. So I'm going to start off saying I've been involved in the media quite a lot, particularly during the pandemic, and I'm going to make some points about why I think statisticians ought to be involved with the media. I'm going to say some things about what's changed during the pandemic in terms of, I'll not call it statistic numbers in the media, but actually there are quite a few things that haven't changed. I'll talk about what opportunities there have been, some of them missed, to get mathematical and statistical ideas across, and a few ideas about what's worked and what hasn't. And I'll finish, if I don't run out of time, with some advice to statisticians on how to work with journalists. If you've heard me speak before, you're bound to have heard some of that part before. So the first part is about being involved with the media, and I'm going to talk about what is called mediation by scientists. In English, mediation can mean a lot of things. Here I'm talking about it in the context of going between the science and the public, intervening in the process by which scientific and statistical ideas are communicated to the public. So that's what I'm going to talk about there. And I'm going to present some data on why it might be important to do this through what might be seen as rather old-fashioned media. Here's a chart produced by Ofcom, which is the UK government department that regulates communication in most senses, not print journalism, but TV, social media, the internet, also the postal service, the telephone service, and a whole lot of things like that. And they've been doing a survey which started in March last year at the beginning of the pandemic on coronavirus, and it asked various questions about where people get their news. This is taken direct from one of their websites, and I am absolutely not saying this is a good presentation of statistics. It's not. It's a terrible presentation of statistics, but it allows me to make a few points. And those points are as follows. If you just look at this, all right, you can't read what it says. It says traditional media, and that is broadcasters, newspapers, and radio. And this is how many people in the survey said they'd use those sources to get information and news about the coronavirus outbreak in the last week. And there's data from March, from November last year, and very recently, early June this year. And you'll see that this is kind of, these are the groups here. That's the kind of highest lot. People are not getting so much information about coronavirus that they once were, but they're still getting it from traditional media much more than other media sources. And if we look at this one, which is the most important source for you, well, it's TV. And traditional media, which includes TV, is right up there. That's sort of 70% or more consider that to be the most important source. So they're getting information from the radio. They're not getting much of it from print newspapers, but they're getting it from the radio, from the television, and to a much lesser extent from things like WhatsApp and Facebook and family and friends, or at least that's what they told this particular government department. Here's some more information. This is the digital news report, which is produced every year by the Reuters Institute for the Study of Journalism at Oxford University. It's very much worth a read. It's a digital news report, but actually it talks about other things than the digital. And it finds out some very interesting things this year on worldwide on trust in the media. It's based, this is just a few very selected findings. It's based on surveys in 46 different countries. These ones are done in January. Trust in the news has gone up in the wake of the coronavirus pandemic, particularly in news from what you might describe as conventional old-fashioned sources. But trust in the news, this is their wording, it's slightly strange, from search and social, that's social networks and things like that, has remained broadly stable. So there's always been a gap that people do trust more what they hear from the news on the TV and newspapers and radio, and that difference has grown during the pandemic. And in a lot of countries, particularly in Western Europe, people are trusting what were already trusted news brands more than they were. I think that's very interesting. Many people have said, no, it's going to be the other way around, and look at all these misstatements in social media and things like that. But they don't actually seem to be as important as you might think. Overall, what I'd say about this is that people have been getting most of their trusted information through traditional media outlets. And if we want to get through to the public with what we want to say, shouldn't we just work through the media? The media have much bigger audiences than any of us could have personally. So if what we're interested in is breadth of impact rather than detailed impact, surely we should work through the media if we want to get a wide audience. But how to do it? Well, there are many ways. I'll just talk about some. This is a slide I've used in various forms for many different purposes, and it describes the very long route which it takes for a research outcome to get through to the public through the media. So what happens is some scientists, some statisticians, whatever, do some research or some analysis, and hopefully that will lead to a paper or conference talk, or if they're government statisticians, through a data release. Now, some of those things will be released by different people, by PR people, by press officers to the media in the form of a press release, a media release. People who work in journalism get hundreds of these things a day. A few of them turn into media stories. That's written by the journalist. A different journalist writes the headline, and the reader decides to read it or not to read it. So the point about this is that's just one route. Each stage might or might not lead to the next stage, and each stage involves different people who've got different motivations. And if you're going to work with the media, you need to understand something about this. You just simply do. But it's more complicated than that. And I'll use the complication to explain where I come in. That's more or less the same thing. One point is that there is social media. So what might happen is the scientists, the statisticians might tweet on Twitter about this stuff. The press officers might also tweet about it. Those tweets might be read by the public reader directly, by people who are producing the media story. And that might all affect things. But there's also another opportunity for mediation and intervention in this process. The media release comes out, or some independent statisticians or scientists, or whoever it is, might see the paper, and they may independently comment on it and try to get that comment into the media story. Now, before the pandemic, if we go back a bit, that was relatively easy to do because particularly if it was a journal article, very often there would be an embargo. That is, the media would be told, this is going to be published in the journal on such and such a date in 2 or 3 days' time, but please don't post your story until then when it's published. We're giving you advance notice. And as long as the journalist can then go and ask a statistician or a scientist, or the statistician or scientist can find out about it and make a comment anyway, that's a way of influencing what the media says and getting our views across, putting it that way. It's much easier if there's an embargo. And one snag that's happened during the pandemic is because of all the push to get information out there quickly, many research outputs have appeared in the form of preprints that haven't been through peer review, simply in some cases as tweets from scientists and from other people who aren't actually scientists and don't always know what they're talking about. And it's become much more difficult to get that intervention in. But that intervention has formed a major part of what I've been doing during the pandemic. And I do a lot of it through this organization that Jeff mentioned at the beginning, the Science Media Center. That's its webpage. I've been providing comments to the Science Media Center on potential news items involving statistics since 2011. And because I've become known through that to journalists, actually they ask me a lot of questions directly. And I retired from the Open University in 2016 from my full-time post. And since then, well, I've been doing the sort of thing that retired people do, but during the pandemic, I've actually been working, some cases more than full time, on doing this kind of commenting and working with the media. I also do things like training journalists, talking to journalist students, training press officers in science subjects, giving talks to anyone who will listen to me, and that kind of thing. So there's more to it than that. So just a few words about what the Science Media Centre is. The UK one was founded in 2002, and the idea is to provide, it's a sort of independent press office, it describes itself as. It aims to provide accurate and evidence-based information about science and engineering, NB not social science, through the media. And it does various things. It runs press briefings. It does this commenting that I mentioned. It generally supports scientists in media engagement by helping scientists, and including statisticians and mathematicians, with training. And it supports press officers. It's very widely funded in order to retain its independence. The main users of its service aren't the public. They're science and health specialists in the UK, particularly in national daily press and the major broadcasters. There are similar organizations in several other countries now: Australia, New Zealand, Germany, Canada, Taiwan, and most recently a sort of one across sub-Saharan Africa that started up last autumn. And there's a rather similar service in the USA called Sciline. It's based at the AAAS, the American Association for the Advancement of Science. And from March this year, there's an international vaccine media hub, which has been providing information. This is actually funded by Google, and coordinated through the Australian Science Media Centre. But anyway, that's what happens. I should say this isn't all I do in terms of working with the media. I do appear in TV and news and TV and radio news programs of various sorts. I tweet a bit, not much. I deal with journalists direct. Occasionally I've written pieces in the traditional media and in blogs, but this is a very important part. Now, I'm going to stop talking about those. I hope that's made the case that why I see it's important to collaborate with journalists. But first, before we get into the detail, a coronavirus example, or 2 UK statisticians sucked into German Twitter storm, shock, horror. So what happened? This is quite a long and slightly bizarre story. It goes back to April, end of April last year. This was after the first peak of the pandemic was beginning to die down in Western Europe, at any rate. And there'd been lots of lockdowns, and people were already beginning to discuss, people were beginning to be particularly concerned about the effect on school children and learning, and asking, when can schools reopen? And that was happening across Europe. Arguments were going on about it in the US, in the UK, and in Germany too. And on the 29th of April last year, this preprint appeared on a web server, not a standard preprint server, a web server which belonged to the Charité Hospital and Research Center in Berlin, in Germany. That's what it's called, an analysis of SARS-CoV-2 viral load by patient age. It has a whole bunch of authors. The first author is a mathematician, not a statistician. That's quite important. The lead author, Christian Drosten is an extremely well-known virologist, not internationally, but also somebody who has a fairly high media profile in Germany, who has a podcast on COVID, which has been running ever since the pandemic began and is generally quite well respected. And there's a whole bunch of colleagues of his. And what did this say? Well, this is an abstract data on viral load. Basically, they got data from routine testing of people to see if they had the virus. And then they did an analysis of variance and they found no significant difference, these are my emphases, between any pair of age categories, including children. And the data indicate that viral loads in the very young do not differ significantly from those of adults. And then they get into the policy. Based on these results, we have to caution against an unlimited reopening of schools and kindergartens. Children may be as infectious as adults, or in terms of what the press actually said, children are as infectious as adults, but the authors didn't say it that way. This became to my attention and the attention of David Spiegelhalter, who was also involved in this, not because we read the preprint, but because the discussion was going on in the UK, and there was lots of people saying and providing scientific evidence to say that actually things are fine with children. You know, as long as we're a bit careful, we can reopen schools, at least for younger children. And various pieces of evidence were being presented. But this preprint always came up as often the only piece of evidence, the only piece of data on the other side. So let's have a quick look at the sort of thing it said. The first thing to point out is that actually they divided the data up into various categories, and you probably can't read this very well. These are split up by age, 1 to 10, 11 to 20, 21 to 30, and so on, 10-year age groups. And they did most of the analysis based on these categories. That's not necessarily wrong. It wasn't totally helpful. But the obvious, going up here, is the log of the viral load. So, you know, the higher you are up here, the more likely you are to be able to pass on the disease to others. It's slightly more complicated, but that's the general pattern. And what do you see here? Actually, the most obvious thing is there aren't very many young people in it, particularly not the ones under 10. So the information is going to be much less precise. It looks, I mean, this is a rather strange diagram, but it looks rather as if the figures are kind of higher for these age groups up here. Once you get up to these older age groups, maybe not. And they did use another categorization as well. Kindergarten age, I can't remember what they said GS stood for, but age 7 to 11, high school, university, and then loads of adults and loads of older adults. They did pretty well everything in terms of this. But the main point is there's not much data on the younger children. So anyway, David Spiegelhalter and I looked at this and we decided that they'd got the statistical analysis wrong. Now, what we would have done about this in another circumstance was to write to them and say, look, that's wrong. Can we help you with this? Can we explain why it's wrong? And but we didn't do that. Instead, we put out a blog post about it on David's blog. And well, I won't go into the detail because in a sense, the detail is not very important because the point here is the context in which this happened. Is SARS-CoV-2 viral load lower in young children than adults? Jones et al., that's a preprint, provide evidence that it is, in spite of their claims to the contrary. Now, we published this, we posted this on David's blog in late May 2020. This is almost a month after the original paper came out. And we weren't the only persons to say this. This had already been pointed out by various statisticians in Germany. They put out preprints about it. They blogged about it. They tweeted about it. And in particular, a very senior Swiss statistician, Leonhard Helt, had pointed out what was wrong with it in some detail. So we weren't the first to do this, but in a sense, we were the first to do it as publicly as we did. And that's kind of crucial. So what happened next? That's the 25th of May. It was a Monday. I remember it well. This is a page from the website of Bild-Zeitung, which is the biggest selling German newspaper. And in sort of Anglo-Saxon terms, English and American terms, you'd probably describe it as a tabloid. It's not the best description, but it's more like that than many other styles of newspaper. It's pretty populist and has a certain, what you might call, abrasive style. And what they say here, this came out on the 27th, that is 2 days later, which was the earliest they could get it out after reading our thing. And this is a quote from us, Cambridge professor, that's David, criticizes star virologist Drosten. We recommend to admit the error and to withdraw the study, so that they're putting this across. That I think it wasn't on the front page, but it was very prominent in the printed newspaper. Here's a picture of the great man. That's Christian Drosten. And here's some quotes. Now it's clear the results of the Drosten study aren't scientifically tenable. And, you know, there we are, Sir David Spiegelhalter. That is true. He's at Cambridge. And me, they spell my name wrong, but hey, that's a newspaper. And we are very important, and we see important problems with the study, and you know, and then it praises us to the skies. We count as luminaries in our discipline. We're listened to internationally, and we really say this is a load of rubbish. And they did inquire of David, and he said he had nothing else to add. They inquired of me as well, and I said the same thing. At least we weren't going to say it to Bild Zeitung. We might have said it elsewhere. This was being really quite prominent. Now, this was 2 pages, 2 days before in Bild. Drosten's study about infected children grossly wrong. How long did the star virologist know about this? And, you know, this is kind of making the same point, but it's before we'd said anything. They're putting the boot in already to Drosten. And it's interesting to know this is in the politics section of their website. It was in the politics part of the paper, not in the science, not in the health part. This is being politicized really quite coarsely. And a huge Twitter storm ensued, a huge Twitter storm. Things that we carried on tweeting for a bit. We tweeted there to publicize the study in the first place. But it all got a bit hot on Twitter. People were saying we were idiots. People were saying Drosten was an idiot, you know, just about anything. And so we stopped. And actually what we did was said, we're not going to speak to the press in Germany or anywhere else. We issued a statement through the German Science Media Center saying that we don't support these personal attacks on Drosten, but we do think his study was wrong. And that's what we did. And the thing is, this went on for months. To be honest, it is still going on. I still get likes on the tweets that I made more than a year ago about this study. It's still going around in the German media. I get tweets on people who attack David and me for making these comments. It still goes on. Well, what happened next? We've got to get the end of this story. That's the original preprint. Under pressure from us and others, it was replaced by a new, much improved version, which sort of came to slightly different and more subtle conclusions. It has to be said that despite Christian Drosten saying, oh yeah, the statisticians, yeah, we got this wrong, he did make various comments in his podcast saying that, oh, these statisticians, they don't know anything about virology. You know, actually, I knew already, and, you know, they've just got this wrong. Well, what, if anything, does this teach us about the process? I think you have to imagine what would have happened if the preprint had come out in another year about some much more minor infection. Well, we probably wouldn't have even seen it. And if we had, we'd have done what one is supposed to do with a preprint. We'd have commented to the authors. We may have done it in public on a preprint archive. And we certainly wouldn't have got involved in the public way if the politics hadn't already been put in there by the original authors and continued by others, including Bild. Now, Christian Drosten, as I've said, has a strong public profile in Germany. The debate is and was polarized there. But there's a question, how far should we have checked on the situation in Germany before we got involved? Because essentially we didn't. I could have done this. I've spent some time in Germany. My German's used to be pretty good. I can certainly read German fairly well. I did not look until the morning when we were about to publish the thing. And I had actually noticed there was a fuss going on in Bild. But I thought, we'll put it out anyway, it'll all be fine. And it does raise questions about to what extent, when working with the media, we should hold back or alter what we say because of the political situation that's going on. And I really don't have an answer to that. I mean, I should say this example, although I've put it high up in the talk, isn't typical of what I personally do because it's direct communication on a matter of policy, not working through the media. In fact, we avoided working through the media. So moving on, what hasn't changed about the numbers in the media? Well, I'd say what hasn't changed is that the media are full of statistics, or at least full of numbers. And they're there for all kinds of reasons. They always were. I used to give public talks about statistics in the media to various audiences. And because of this, I used to go through newspapers. This was when there were more newspapers than there are now, and talk about this, look up to see what they said. And what I found, there were numbers everywhere, obviously in the business section, because also numbers to do with business and finance. In the sports section, people like numbers in relation to sport, but also in politics, in economics, in science, on health and the environment, but also in things which are perhaps less serious. Some infographics are less serious. And the newspapers, the media are and still were and still are to an extent based on silly stories, based on dubious surveys, which have been done simply for public relations purposes. Tiny little fillers at the bottom of newspaper columns, because you can say quite a lot in a little space that you found in the newspaper, just about everywhere. And they're there because they're the basis of the story, but also I'd say for rhetorical purposes, to change the nature of the argument, to increase credibility and trustworthiness, or in some cases, just to make the newspaper page or the web page look better. There was a habit amongst several UK newspapers and elsewhere to some extent as well, of simply pulling out, having a sort of pull quote of one number from a story. Some of these were completely ludicrous. Here's my favorite example. This is quite old. It's from The Guardian, a UK more serious newspaper. There was obviously a space on the page. This was a story about some hikers who'd accidentally strayed over the border into Iran, and they'd been arrested and were going to trial. There were no numbers in it, in the story, other than the date when the trial was going to happen. So they pulled that out as a major important thing. I mean, it was months ahead. I mean, this is just silly, but that's what they did. So that's what kind of statistics they used to be in the media. And as I said, the reason for these are quite varied. You might describe it as the unreasonable persuasiveness of numbers. Numbers tend to be seen as objective and value-free, even though we know they're not. And there's this awkward thing about statistics. I think this idea is mainly due to the French statistician Alain Desrosières. He argues in a very thick book, which is much easier to read in French than English. The English translation is very tedious. Statistics is a fixed basis for argument. That is, people can use statistics for arguing about levels of employment, unemployment, whatever it might be. But there are also arguments about how the statistics ought to be used to measure those things. And because those arguments are working at different levels, there's all kinds of confusion. There are tensions at every level. There are all sorts of communication difficulties. And that's awkward. I mean, you're probably aware of this with students. Some students have a tendency to believe anything that's put across as a number, but also to come out with the line that where there are lies, damn lies in statistics, and it's all a load of nonsense. I mean, in most cases, the truth, if there is one, lies somewhere between those positions, but people seem to manage to be able to hold both those positions at the same time, and that makes using these things really rather awkward. Numbers are used as devices of rhetoric. I don't think there's any, I mean, there's lots of research evidence for this, which I'm not going into the details of. Numbers can be used to shut down an argument. The UK Prime Minister in the 1980s, Margaret Thatcher, was very good at this. She would be better briefed on the data than anybody else. And she would say, blah, 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 some whole list of numbers. No one could argue because they didn't know what was wrong with the numbers because they hadn't thought about it. It shut the argument down. And also in media stories, numbers can increase the credibility. There's a lot of evidence that they do this to a really major level. So that hasn't changed in the media. So what has changed? Here are a few points about what's changed. As I've said, there've always been statistics there. They've always been like that. But what I suspect has changed isn't so much the column inches or screen minutes of coverage, probably gone up a bit. It's the news value, the perceived importance of the numbers, and in particular, the type of journalists involved. In the UK, at least, and I know this is true in several other countries, the major journalists who work in health and science often know a lot about this stuff. They're numerate. Some of them have PhDs in scientific subjects and so on. They know what they're talking about. Political journalists know what they're talking about on other matters and not this. And they have changed the nature of the debate about scientific results across the country. And that's caused interesting issues and some problems. Okay, now I'll get on to what I mainly said I was going to talk about. I'm going to talk about opportunities for getting some statistical and mathematical ideas across in the context of this increased public importance of numbers. And here are just some things where there have been opportunities for improving understanding. And in the light of the pandemic, I'd say necessities for improving understanding. This is just kind of a list, and I'm not going to have time to talk about all of these at all, really, but I'm going to talk about some of them. A lot of the misunderstandings that originally arose are to do with percentages and rates and what you divide by in order to get a ratio, because it's important to consider ratios for many reasons. The question of what's a big number, and is it still a big number if you divide it up amongst the entire population? The distinction between absolute and relative risk. One way of thinking of that is they're numbers with different denominators. The difficulty of dealing with percentage changes in percentages. Some journalists, quite a lot of journalists, have huge difficulty with percentages. And when I'm talking to them, I tell them that if there's one bit of mathematics or arithmetic even that you really must be on top of, it's percentages. And I hope I've had some impact doing that, but probably not. So the issues about getting the right denominator, there's an interesting example I talk about, I have time, where Simpson's paradox arises. There's something I'm not going to be able to talk about, which is error rates in diagnostic tests, the fact there are different error types. Then we come on to a big one, exponential growth, R number and growth rates, which has been horrendously misunderstood. There are differences between stocks and flows, prevalence versus incidence of disease, numbers of people in hospital versus new hospital admissions. I had a huge cross-purposes discussion with a journalist about how it could be that the numbers of people in hospital were falling, but the numbers of new admissions were rising. Oh, the numbers must be wrong. No, they're not. They're looking at different things. There are issues about uncertainty in statistics and about scientific findings generally, and there are issues about modeling, which has been misunderstood, particularly when it comes to modeling the future. So I'm going to start saying some things about percentages and rates. And what I'm going to do on this is I'm going to use an example which isn't about COVID, which I use to teach journalists and journalism students to show the difference between how it's important to know what a percentage is a percentage of. I will get to COVID towards the end of this story. So the science here, this is based on a study which was published in August 2018. The reference comes up later. And the issue is that people whose heart stops, people who have their heart stops beating and they're not in hospital are pretty obviously in great danger. And that's particularly true if their heart doesn't restart after cardiopulmonary resuscitation and or defibrillation, this electric shock. I mean, luckily with Christian Eriksen, the Danish footballer, the other day, he wasn't in that position. His heart did restart. Now, in the past, in the UK at least, and in most other countries, the advice at that stage was to inject adrenaline or epinephrine, if you're Americans, same thing, into the person, because that it was thought would help their heart to restart. But various concerns have been expressed about that, whether that was the right thing to do. So a clinical trial was carried out in the UK, 2014 to 2018, and patients were chosen at random. Patients in this very unfortunate state were chosen at random, either to get an adrenaline injection or to get a placebo injection of salt solution. And that was carried out. Interesting questions about informed consent, given that they're unconscious and in a very bad state at that stage, but that was the trial. Now here, this might have been the headline on the story. Using adrenaline in cardiac arrest results in 40% more people leaving hospital alive. And then kind of the Stanford in smaller writing, but the survivor's risk of severe brain damage increases by 13 percentage points. Well, I don't know how this makes you feel, and how it makes you feel might depend on your experience, perhaps with relatives who've been in this terrible position. But would you want to be given adrenaline on the basis of this headline if you had unlucky enough to have a cardiac arrest outside a hospital? Well, maybe you would. You might think, well, you know, of adrenaline, that puts up my risk of my chance of leaving the hospital alive by 40%, and surely that's quite a big one. And well, this business about brain damage is slightly worrying, but 13 doesn't look like a very big number, and you know, maybe we're better alive or not than not. So you might feel quite positive about it if that was the headline. If I had longer, I'd ask you what you thought about this. That's what I asked the journalism students, but let's carry on. The actual headline didn't say that at all. This is the press release. Using adrenaline in cardiac arrest results in less than 1% more people leaving hospital alive, but nearly doubles the survivor's risk of severe brain damage. Sounds gloomier? Certainly sounds gloomier to me. And that was in the press release, and naturally enough, that's how it was reported. This is one report in the UK press. I've got a whole lot more I could show you. Routine treatment for cardiac arrest doubles risk of brain damage study, you know, and basically this repeats what the press release said. So why did I make up the headline? I obviously made up the headline to make a point, and it's because both headlines are telling the truth based on the data from the research. And that's because there are two ways to describe changes numerically that in this context are called absolute and relative, and there's nothing mathematically wrong with either of them, but they can give very different impressions to the reader. And an important part of being able to critically read this sort of thing is to be aware of that. And just in the context of that, here's a book by Tim Harford, who's an economic journalist who's the presenter of the BBC Radio 4 program, more or less, that Jeff mentioned at the beginning that I worked on for a long time. He recently published a book which is largely based on his experience in working on this more or less program for a long time. 10 Rules for Thinking Differently About Numbers is the subtitle. And you'd imagine this would be a lot of stuff about don't mistake correlation and causation and all that kind of thing. And he does get that to those things, but they're not rule number one. Rule number one is search your feelings. Think about how this makes you feel. Because it's only when you've made conscious in your own mind how it makes you feel that you can think properly about what the numbers are actually telling you. And I think that's very true in the context of this. That's why those two headlines look to be saying different things. So let's just quickly whip through where those numbers come from. This is the paper. Though it was a UK study, it was in an American journal. So they call the stuff epinephrine because that's what Americans call it. It's in Europe, it's usually called adrenaline. And that's what it was. It's a randomized trial. Here's some data from the trial report. I've just taken them from the paper. And what we've got is survived until hospital discharge, 128 out of the 4,009 people randomized to adrenaline. For some reason, this number is slightly different, but perhaps they lost some results. So what you see is 128 of those survived, 91 of those survived. And then it does something conditional. It says, given that they survived hospital discharge, so this is these people, they must have lost records on 2 or 3 of them, 39 had severe brain damage if they were on adrenaline, and 16 had it if it was on placebo. And actually, it's these percentages and these denominators that really tell you what's going on. And of course, they're not in the headlines. They weren't mostly in the press stories. You'd have to find the paper and figure out what the paper meant if you wanted to know this. So what I did, this is my headline, and what I did was I calculated the survival comparison, the one based on these, as a relative comparison. That's 3.2% on adrenaline, 3.2% with adrenaline, 2.3% with placebo. You do the usual calculation, the adrenaline rate is 39% higher. It's about 40%. And actually, if you do it with the exact numbers, it is 40%. So that's kind of fair enough. Now, why this is awkward to think about, this is a percentage change in things which are measured in percentages. And that is awkward to get one's head around. Journalists get this wrong all the time. It's really scary. But I did the brain damage comparison as an absolute comparison. That is doing it by subtraction rather than division. The difference is 31 minus about 18, so it's about 13 percentage points. And that's what I said, it's 13 points higher. So relative by division, absolute by subtraction. This is what the actual headline did. It did it the other way around. It did the survival comparison by subtraction, an absolute difference. 0.9 percentage points, that's less than 1%. They should have called them percentage points, but they never do. And the brain damage comparison is relative. Those are the two rates, 13%, 17.8%. That one is 74% higher than that, and maybe that's close enough to be nearly double. Now, they could have made other choices. They could have made one comparison. They could have made them both absolute. They could have made them both relative. They could have looked in many different ways, but that's actually what they did. Now, usually what I and other people who talk about this stuff say to journalists is that we recommend using absolute figures wherever possible. That is talking about these numbers and talking about how the difference between them, that's what you get if you subtract one from the other. But look at this. Here are some data from the original trial reports on the Oxford AstraZeneca COVID vaccine, which said it had 70% efficacy. But 70% of what exactly? Now, what went on in this, You know, I could have talked about later results on effectiveness in the real world, but I'm talking about this one. Again, I've used this with a public audience. Participants were randomized either to get the real vaccine or a control injection, a placebo. And the outcome for this particular analysis was whether they had symptomatic COVID defined in a certain way. And what happened was nearly 6,000 participants had the real vaccine and 30 of them got COVID according to that definition. That's half of 1%, 5 in 1,000. And there were about the same number who had the control injection, and 17 in 1,000 of those got COVID. So the reduction in risk is, you get by subtraction 1.2 percentage points. That's an absolute risk reduction. But if you measure that as a percentage of the risk in the control group, it comes to 70.6%. It's a relative risk reduction, and that's the 70% efficacy. Now, actually, they used a slightly more fancy statistical method, and they got 70.4 instead of 70.6, but it essentially amounts to the same thing. And the question is, why use relative in this context when people like me are always telling them to use positive? Well, the answer is that what's going to happen is going to depend on the overall infection risk, which varies from place to place, from country to country, from time to time, from age group to age group. But it so happens that often with vaccines, the relative risk reduction doesn't change much as the absolute risk varies. It's just a fact of life. I've been discussing with various people why it's like that, and nobody really seems to know. But it is like that. Now you can present this graphically in various ways. Here's 1,000 people. These are the ones without the vaccine, and those ones get a bad outcome. That is, they get COVID. Here's with the vaccine, and the nice little ones in yellow are better with the vaccine treatment. They don't get COVID, and they would otherwise have got it. But the main thing that this shows is most of them aren't going to get COVID anyway, or they weren't in the sort of circumstances that were put about. Now, this has been used in other ways, because this is not a good graphic, because your eye's drawn to all this green stuff here, and it puts over one point and not the interesting part, which is the comparison between these bits here. Here's something I should say at this point, that I have a slight conflict of interest in relation to this. I do not directly advise the UK government, but I am on an advisory group about the presentation of data to the public. I didn't actually advise on this one, but I'm just trying to be open. I have had some involvement with this. This is a slide from a presentation used in a press release, in a press conference by the UK government, describing reasons for loosening the restrictions on people. And this shows the reduction in hospitalizations from the Delta variant of the virus after different amounts of doses of the vaccine. Now, this gets rid of all those green people on the last thing by just talking about people who would have been hospitalized if they hadn't had the vaccine. So there's some of them, there's 100 of them there. And there's something here for 2 doses as well. And this is what happened if they would have been vaccinated. This shows the uncertainty. We don't actually know how big that reduction is, but either way, it's pretty substantial. And I think that is a pretty good way of presenting the data. Various other people have looked at this in different ways. And actually, on the whole, I think the communication of vaccine effectiveness has been pretty good. And I think people do understand what the percentage means and what it's a percentage of. So that's one thing that I think has been done well, even though it's actually quite tricky if you start worrying about the details. Moving on to something else. This is an example that came up just a few days ago. Skeptics get the numbers right, but the interpretation wrong. It's another example of why the denominator matters if you're using rates. So this is from a kind of skeptic news site in the UK. People who are skeptic about COVID. And what they did was they said, they're quoting from, I mean, they gave details of how they did this. A document produced by the Public Health Authority in England, Public Health England, on variants of concern. And what they did is they worked out the case fatality rate for people who'd been vaccinated and people who'd been unvaccinated. And they found that it was much higher for people who'd been vaccinated. I mean, way higher. 250 is a lot bigger than 71. So surely being vaccinated is making you more likely to die, so don't get vaccinated. It was slightly more subtle than that in the original version, but to be honest, not much. So how did this come about? This is the technical briefing from Public Health England that came out, that provided this. And here are a few numbers I've taken from it. I've added together some columns, but in the same way that this Skeptic news site did. And these are the number of cases, all cases, fewer vaccinated than unvaccinated, but they also split it up by age, under 50s and over 50s. And what you see is that very few of the over 50s were unvaccinated in the period they were looking at. Only about 900 of them out of the total of those. It's really not very many, whereas the people who were unvaccinated were mostly under 50. Quite a few of them were vaccinated, but many of them weren't. And those are the numbers of deaths. There were more deaths in the vaccinated group, even though the total number was less. And so you can see that's where they got those numbers. But if you split it up by age, it's different. The first thing is there were hardly any deaths in people under 50, whether they were vaccinated or not. There were rather more deaths in the older age groups, as we know, because that's how this virus works. And we also know the vaccines aren't perfect. And you can see what's coming next. If you work out the rates, those are the rates. Actually, I don't get the same numbers that they got. Either their arithmetic's wrong or mine is. They got 250 and 71. But if you accumulate this over both groups, over both age groups, yes, the death rate is higher in vaccinated people than unvaccinated people by some margin. But if you look at the two groups separately, the death rate in unvaccinated over 50s is far bigger than the death rate in vaccinated over 50s. It's about 4 times as big. And right, there's not much difference for those, but clearly they're not estimated very well. There are only a few deaths, but that one is actually slightly higher. So what's going on here? Well, it's Simpson's paradox. If you know what Simpson's paradox is, that is a different pattern in disaggregated data than what you get if you aggregate the data. And that's a thing that people often don't believe until you've shown them an example with numbers in. There are simpler examples with numbers in. I don't think it helps in explaining why this is wrong to call it Simpson's paradox, but to explain that it can happen. And it's obviously because of the very different nature of the pattern of being vaccinated in younger and older people. And the fact that there's an obvious explanation for that because of the way that vaccines have been rolled out in the UK and most other countries, vaccinate older people first. It just makes it plain that there's no point in looking at these overall averages. They're just not giving the right picture at all. And that's an issue. So I'm going to move off percentages and things like that now. And I'm going to say a bit about issues with exponential change, R numbers, and all that kind of thing. Well, you'll all be aware that there have been headlines all the time talking about exponential change. This is one from a Portuguese website for expatriate people. They're all over Twitter, and the things just keep coming faster and faster and faster and faster and faster. Some of them are making good points, some of them are not. And finally, here's one about the football. The England scores have been increasing in a geometric progression, so we're going to have 8 goals tonight against Denmark. I don't think so, but you never know. I hope if there are 8, they're 8 for England. Here's a headline, well, beginning of an article from an English language news site in Switzerland, fairly recently in June. Swiss cases fall as UK cases turn exponential. And it's interesting. This is the pattern. They've taken the data from the admirable website, Our World in Data. Yeah, the UK ones have been going up and the Swiss ones, well, are a bit wobbly, but it is a small country. And they're kind of falling. And it's sort of interesting that they refer to this as exponential. They don't refer to this as exponential. Maybe it is. Let's have a look. So here are some slightly more up-to-date data from Our World in Data. This goes up to July the 3rd. And this shows, I put in Germany as well because it's slightly less wobbly than Switzerland, but it follows a kind of similar track. And there the UK one's going up. Yeah, they seem to be going up faster and faster. But of course, this is Our World in Data. It's a very good website. You can change to log scales with a simple click, and it looks like that. And actually, it is pretty straight on a log scale in the UK. That is pretty much like exponential growth. But you kind of look, has it been exponential decline in Germany, at least until just a few days ago, and maybe in Switzerland as well? They look not too far from linear. So why is the newspaper referring to one of them as exponential and the other one as kind of not exponential? Well, we know that happens all the time. We know that exponential has been taken to be a kind of synonym for rapid growth, which is a real problem, I think, in the context of COVID. that is a mathematical term has been taken over into the everyday language, but with a completely different meaning. Now, in a way, the most obvious example of this having happened before, I think, is with the word parameter, which in everyday speech in English is taken to mean something more like perimeter or boundary or something like that. Now, that's awkward. You have to know in which context people are speaking. But then again, it's very rare for people in everyday life to have any use for the mathematical meaning of the term parameter. So if they get it wrong, that's annoying to mathematicians and statisticians. But actually, in life, it's not a big issue. But it is when it comes to exponential growth, I'd argue. Now, there have been various attempts to explain this to the public. I should say that at the beginning of the pandemic, I think the media and scientists have actually made a pretty good job of explaining how the R number, the reproduction number worked, and how that could lead to exponential growth. But it seems to get forgotten about later. This is an article that's on the website, which is actually mostly written by academics, by university people. It started in Australia. It's called The Conversation. The author, Christian Yates, has been very prominent in talking about the pandemic. He's more commonly known as Kit Yates. I don't know why he uses his full name on this website, but he does. And he explains in this article what it really means that coronavirus is growing exponentially. He explains it very well, I think. But this is a website which is not read much by the general public. Here's another one. This is a BBC website. This is not on their news pages, but I found it from a link from their news pages. And it turns out, many of you probably already knew this, that there's something called exponential growth bias. It's a simple mathematical mistake. We don't understand exponential growth. So we're biased. It's a numerical error. We don't get this. We're idiots. It actually, again, goes on to explain it pretty well. But I do wonder how many people have actually read this, because it's important in terms of one's understanding of what to do about the pandemic. Now, of course, there's nothing new about this, whether you call it exponential growth bias or anything. You're probably aware of this, the wheat and chessboard problem, or often talked of in terms of rice grains. And the idea is, got a chessboard with 64 squares. You put 1 grain of rice or wheat on the first square, 2 on the second, 4 on the third, and so on. How many grains of wheat would be on the chessboard at the finish? And there are various stories connected with this about somebody asking for this as a reward and so on. Well, if you work out what it is, it's some absolutely mammoth number there, which turns out in wheat, according to Wikipedia, to be about 2,000 times the annual world production, much more than people tend to expect. And this is a very old problem. It was first recorded, according to Wikipedia, again in the year 1256 by Ibn Khaldun, who's a prominent Islamic scholar. And that's not the only thing. I don't know if this works in every country, but this is...
Kevin, yeah. I think about 4 minutes left.
Yep, okay. I haven't got that much left.
Okay.
Maybe slightly more than 4 minutes. In a lake, there's a patch of lily pads. Every day the patch doubles in size. If it takes 48 days for the patch to cover the lake, how long would it take for the patch to cover half the lake? This is a well-known riddle in the UK. People put it in Christmas crackers, if you know what this means. And the point about this is that people get it wrong. I mean, the answer is obviously 47 days. It's obvious to me. It's not obvious to many people. They say, oh, 24 days, 30 days, or something like that. People do not understand this. And this is a problem in relation to COVID. Now, there's been research on misperceptions of exponential change in the context of COVID-19. Here are 4 studies that I found. The research paradigm here is basically to give people some information on how cases have been growing and then to get them to project it into the future. They do differ a bit. And they found various things. The first one was done by some researchers in German universities, but on participants in the US. This was done right at the beginning of the pandemic in March last year. And they said the participants mistakenly perceive the growth in linear terms, conservatives more than liberals. But if you tell them not to do that, well, actually, they do rather better. Well, it depends how you tell them. I think this is a more interesting one. This is by some Swiss authors, and they talk about framing, how you frame the question. And they say, well, growth can be framed in terms of doubling times rather than growth rates. So don't say it goes up by 3% a day. Say it doubles in such and such a period of time. They're still biased, but it reduces it. And they looked at other effects of framing. There's another study that's authors, I think they're all of Indian origin, judging by their names, but they're in 3 different countries. This used a wide range of different participants, but only about 400 of them. And they found one thing bias being significantly a negative associated with non-compliance with safety measures. If you don't understand how it's growing, you're less likely to comply with the safety measures. That's correlation, not causation, but it's quite interesting that that was found. They found a thing which I don't think will generalize. If you show the prior data in terms of numbers as opposed to a graph, there's less bias. Interesting. I would like to see that replicated. And here's another one done by a broad group of researchers based at the University of Salzburg. And they framed this in very different ways. They looked at the use of log scales, and they found that people did much better with log scales, but their participants were relatively well educated, so maybe that's not too surprising. But the mistakes still go on. This is from the Mail Online, what's alleged to be the world's biggest news website. This is talking about the R number. The R number, it says, has not moved in 3 weeks. In the UK, they give it as a range to allow for uncertainty, and it's only published once a week. And they're talking about the fact that it hasn't changed. It's above 1, but it hasn't changed. And they're saying that adds to evidence of the outbreak slowing. Hang on, no, it doesn't. You don't understand this at all. This is after saying in the headline that actually it was all going up. And here's a more recent one. This is just from a few days ago, last Friday's. Our number in England falls slightly to 1.1 to 1.3. They've moved the range down again, but it's below 1, despite the rise in cases. Well, actually, you'd expect the rise in cases if the R number is above 1. This is really common. So I'll quickly go through a couple more things. This is essentially all I've got. I'll briefly talk about why it's important to communicate uncertainty. I'm not going to tell you about how to communicate uncertainty. I could give some references on that. 2 very important papers about this came out in the medical press in the autumn. This one is about, it's by some medics, it's about explanations to patients and citizens about the personal risk of COVID-19. And they looked at communication to people who are being advised to shield themselves because of being a particularly high risk, and advice to given to people when they got a positive test result. And what they said, put all these up, whoops, hang on. What they said was, these pieces of advice contain no reference to uncertain, despite the fact they're based on uncertain evidence, and they gave various reasons about why that can destroy trust if the evidence has to change later. Better example of this is advice about mask wearing, where we were originally told they don't help. And then when we were later told, oh, they do help, people didn't believe it. And they're basically saying you should admit the uncertainty. And of course, any statistician would say that all the time. Here's another paper. This was an editorial in the important medical journal, the BMJ. COVID-19's known unknowns. The more certain someone is about COVID-19, the less you should trust them. And they gave various reasons for why that was a slight exaggeration, but an important thing to say. Now, there's a lot of information about how to communicate uncertainty and about the fact that if you do communicate it, it doesn't destroy trust. It helps people to be in a better position to go forward, but it still just doesn't happen enough, and it hasn't happened enough throughout the pandemic. So now I will say about 10 words about communicating modeling. Now, there's been huge prominence of modeling, mathematical modeling, statistical modeling during the pandemic. And I think this has been really badly communicated. And I'd argue that many people at every level don't understand what's going on in modeling. I'd go further and say that some of the people who are actually doing it don't really understand what they're doing. At least they certainly don't describe it well. And I link all this back to this famous statement by George Box, the Anglo-American statistician. He said this in various forms: all models are wrong, but some are useful. And that the skill of a statistician, a modeler, is to know how far to push them while they're still useful. That's really important. Now, there's nothing new about this. This is a statement which is put across in many other ways. The map is not the territory. It's a very common way of stating this. The map is a simplified representation of the territory. The model is a simplified representation of reality. And it can be useful for some purposes. It can be not useful for other purposes, and the skill is to know which it is. And the skill, if you're communicating, is to communicating which it is. Now, the trouble is, many of the modeling exercises that have been done during the pandemic have been predictive modeling. And that is even worse, because you're trying to produce a map of a country that doesn't even exist yet. You're kind of predicting how it might change, modeling how it might change, and you might turn out to be wrong. So just to finish off, I will give the standard advice I give to statisticians on working with journalists. And this is to deal with the following issue, that there are sort of two competing cultures. This is an exaggerated version of what statisticians think of journalists. Journalists are enumerate. There's some truth in that in the UK. There's no requirement for numeracy training to journalists. Often they do it anyway, but it's not a requirement. Journalists don't understand quantitative reasoning or indeed any kind of logic. They distort and oversimplify things, and basically they won't listen to us. But this is what journalists think of statisticians. We're illiterate, we're pedantic, we make the story so boring that it doesn't get across, we concentrate so much on the ifs and buts that the overall message disappears, and well, we won't listen either. These are stereotypes, so I think there is some truth in them. And what I say to my colleagues, statisticians, is we need to recognize that journalists are different. They're working in a different context, in a different culture. Their timescales are shorter. They need to work quickly because there's a deadline. And if they don't meet the deadline, it's too late. They may be working in a context where there's a fixed agenda, where their proprietor wants something to be got across. There's this idea of news value, which people find rather strange. It's not what I am interested in, it's what the public in some senses is interested in. And there's a pressure to be personal, to talk about an individual person who has got the disease or has suffered in some way or has been cured in some way. Statisticians are very much trained out of doing that. Don't concentrate on the outliers, concentrate on the general picture. So we're pointing in different directions. But I'd point out that journalists have strengths that most statisticians don't have. Journalists know their audience. Journalists are good at getting things across in a short space and are generally better than we are, better than I am, at telling stories. And so I tell my colleagues, don't just blame journalists for getting things wrong. Try to help them to get things right. They want to get things right, usually, and they'll usually respond positively. So here are a few conclusions. It just repeats what I've said. An important way, in my view, of increasing public understanding of practical and mathematical ideas is to work through the media. There's nothing new about numbers prominent in the media, but they become more important during the pandemic. The pandemic has emphasized big gaps in public understanding, some of which are already known about. This has provided opportunities to improve public numeracy, but they haven't all been taken up properly. And finally, more statisticians should get involved with journalists. So that's me done. Thank you very much.